All right, welcome back everyone to the deep dive. Today we're diving into a design pattern that you're likely to encounter, especially when you're preparing for senior software engineering interviews. It's a pattern you really want to have a strong grasp of, the singleton.
Yeah, the singleton. If you're getting ready for those tough technical interviews, knowing this pattern inside and out really shows that you understand how to design systems and manage objects effectively. That's a big deal for senior roles.
Okay, so let's start with the basics. Why do we even need this singleton pattern? What problem does it solve?
Well, imagine this. You're building a system, and there's a certain class where it just wouldn't make sense to have multiple instances running around doing their own thing. It has to be just one, and everyone needs to be able to access it.
Okay, let's take something everyone's familiar with, a print queue. You don't want multiple things trying to manage the printer all at the same time.
Exactly, or a file system, or the configuration settings for an app. These things need to be centrally managed, just one instance, for the whole system to work properly.
Now, someone might think, well, why not just use a global variable to hold that thing? But the thing is, a global variable doesn't actually prevent you from creating multiple instances of the class itself, does it?
Nope, not at all. And that's the key difference. The singleton pattern is specifically designed to guarantee that there's only one instance of a particular class in your entire system. It's built into the class itself, like a rule.
So with this deep dive, we're aiming to give you that in-depth knowledge of the singleton pattern. We'll cover why it's used, where it shines, how it's structured, the good and the bad, and how you'd actually code it up.
Yeah, we're going to go beyond just the definition. We'll talk about the real-world trade-offs, so you'll be ready to discuss it intelligently during an interview.
So let's get into the why. When you're building a system, what situations screen singleton?
Well, think about a logging service that every part of your application needs to use, or a configuration manager that holds all the important settings. Or maybe you're working with a hardware device like, say, an AD converter, and there's only one physical device to talk to.
Right, so those are some pretty clear examples of where you'd want just one instance to manage everything. And it's not just about preventing conflicts either. What about scenarios where having multiple instances just wouldn't logically make sense?
Absolutely. Like an accounting system for a company. It's tied to that one company. Having multiple instances wouldn't reflect reality and could really mess up your data. Or think about managing connections to a database. You usually want a single pool of connections that's carefully controlled, not a bunch of separate ones doing their own thing.
Okay, so it sounds like there are two main scenarios where the singleton pattern is really helpful. First, when you absolutely positively need only one instance of a class and everyone needs a reliable way to access it.
Right, that's the classic use case, when having more than one would just break things.
And second, when you might want to be able to extend that single instance, create subclasses, but you still want the rest of your code to interact with it seamlessly without needing to change a bunch of stuff.
Yeah, that's about making your system more flexible. If you can subclass your singleton, you can introduce new behaviors without disrupting the rest of your code. Like, say you have a basic configuration manager, but then you subclass it for different environments, like development or production. The clients still use the same instance method, but they get the right configuration for their environment.
Okay, now let's get a bit more concrete. What does a singleton actually look like? What are the pieces involved?
So the heart of it is the singleton class itself. And this class has a special operation, usually called something like instance, that acts as the gatekeeper. This instance operation is not tied to any specific object of the class. It belongs to the class itself.
So it's like attached to the blueprint of the object, not an actual object. And this instance method, that's how other parts of the system get hold of the one and only singleton object, right?
Exactly. And the singleton class is usually responsible for creating and managing that single instance.
So it controls its own creation. And what about the other parts of the system, the clients that need to use the singleton? How do they interact with it?
Simple. They don't go around creating new singleton objects directly. They always go through that instance operation we talked about. That's the rule.
Okay, that makes sense. So it's like a controlled access point. And speaking of that, what are the benefits of using the singleton pattern? Why bother going through all this trouble?
Well, you've touched on a few already. First, you have complete control over access to that single instance. The singleton class manages it, so you can do things like lazy initialization, which means you don't create the object until it's actually needed.
Right. That can be good for performance.
And second, it keeps your code clean. Unlike global variables, the singleton doesn't pollute your namespace. It keeps everything nicely contained.
Yeah, so it's better organized. What else?
Well, with subclassing, you can make your singleton more adaptable over time. You can refine its behavior without rewriting a ton of code.
And it's been said that the singleton pattern can actually allow for a variable number of instances, which seems a bit odd since singleton implies just one.
Yeah, that's a good point. While the typical use case is for just one instance, the core idea is about controlling instantiation. So if your needs change and you decide you need, say, a limited pool of objects, you can adapt the pattern for that.
So it's not just about the number one, it's about controlled creation. And there's one more benefit. Using a singleton class with an instance method is more flexible than just relying on class-level operations like static member functions.
Absolutely. Static member functions have limitations, especially with subclassing. In many languages, they can't be virtual, so you lose polymorphism. The singleton pattern gives you more options down the road.
Okay, now let's talk about the tricky parts. What are some of the challenges when implementing a singleton?
Well, first and foremost, you've got to make sure you actually end up with only one instance. The usual trick is to make the constructor private or protected so nobody can create instances directly from outside the class. Then you provide that static instance method, which creates the instance if it doesn't exist and stores it internally, maybe in a static member variable.
So the instance method is the only way to get a hold of the singleton, and it often uses lazy initialization, so the object isn't created until the first time someone asks for it.
Exactly. Now, you might be wondering, why not just use a global object or a static object in, say, C++4? Well, it's not that straightforward.
Yeah, it's important to understand this, especially for those interviews.
Right. So first off, simply declaring a global object doesn't guarantee you won't end up with more than one. Someone could accidentally declare another one somewhere else. And then there's the issue of initialization. Sometimes you need information that's not available when static objects are initialized.
And then there's the whole mess of the order in which static objects are initialized in different files, especially in C++.
Yeah, that can lead to nasty dependencies and errors. The static instance method with lazy initialization avoids all of that.
And we've also seen other approaches, like in Smalltalk, where you can override the new operation and use a class variable to hold the single instance.
Yep, different languages have different ways of doing it, but the core idea is the same. Control instantiation from within the class and provide a single point of access.
Okay, so another challenge with singletons is how to handle subclassing. What if you want to use a specialized subclass, but still have everyone access it through the base singleton's instance method?
One way is to build the subclass selection right into that instance method. Like in the maze factor example, they used an environment variable to decide which subclass to create.
Right, so the instance method checks that variable and creates the appropriate factory.
But the problem is, every time you add a new subclass, you got to go back and change that instance method. It can become a maintenance nightmare.
So what's a better way to handle this? The idea of a registry of singletons was mentioned.
Yeah, the registry. This is a more flexible approach. Instead of hard-coding the subclass choices in the instance method, the subclasses register themselves with a central registry.
So it's like a directory of singletons. But how do they register themselves?
Usually through their static initialization. Like in C++A, you can have a static object in the subclass that calls a register method on the base singleton class. It provides its name or a unique identifier and maybe a way to create an instance.
And then when someone calls the instance method, it uses some configuration value like an environment variable or something from a file to look up the right singleton in the registry.
Exactly. That way you can add new subclasses without touching the base singleton code.
It sounds a lot cleaner and more adaptable. But it was mentioned that this static registration approach could lead to creating all the subclasses, even if you only need one.
Yeah, that's a trade-off. The registry is more flexible, but it might have a bit more overhead at startup. It depends on what's important for your application.
Okay, going back to that maze factory example, it was a good way to see the singleton pattern in action. You have a single factory responsible for creating all the maze elements, and everyone accesses it the same way.
Exactly. The instance method provides that consistent access point, regardless of whether you're using the base maze factory or a specialized one like bombed maze factory or enchanted maze factory.
And it's interesting to see how the singleton pattern is used in real systems. We saw examples like Smalltalk's change set current, which manages code changes, and the relationship between classes and metaclasses in Smalltalk, where metaclasses themselves are like singletons.
Yeah, those are classic examples. And we saw how the interviews toolkit uses something similar to the environment variable approach to select the right subclass for its session and widget kit classes.
Finally, it was pointed out that other patterns like abstract factory, builder, and prototype can be implemented using the singleton.
Yeah, the singleton can be like a building block. You might have a single abstract factory object that creates families of objects, or a single builder object that assembles complex products, and so on.
So wrapping it up, the singleton pattern. It's a key concept in software design, especially as you get into more senior roles. It's about ensuring you have only one instance of a class and providing a controlled way to access it.
Absolutely. And understanding when to use it, how to implement it, and the trade-offs involved is essential for any senior engineer. It shows you can think about system design and make informed decisions.
All right, here's a question to ponder as you continue your interview prep. Thinking about the environment variable approach versus the registry of singletons, when would one be clearly better than the other, particularly in terms of testability and maintainability?
That's a great question. You got to think about how easy it is to test different configurations and how well the design will hold up as the code base grows. The registry, with its decoupling, often has the edge there, but it does add some initial complexity.
Well, that's been our deep dive into the singleton pattern. Hopefully, you're feeling more prepared to tackle it in those interviews.
Yeah, remember, keep learning, keep asking questions, and keep coding. That's the best way to master these concepts.
Thanks for joining us on the deep dive.